Right, good day, folks. This time around, we are diving into a computer science lesson, and our focus is on a database. That's a single table database. Normally, this will be basic, covering a scenario where maybe relations might not really be necessary. So, we'll be looking at perhaps a single table within that database itself. Please remember to like and share, as well as subscribe to the channel so that you can always receive latest updates should productions be made. Right, so let's dive in. The objectives of this session is to say by the end, one should be able to define a single table database from given data and storage requirements. Also choosing and specifying suitable data types. For instance, if you want a primary key, which type of data does it store? So that will be the data type. Also choosing an appropriate primary key. Why do we need a primary key that's unique identification of records or rows within your table? Also performing a query by example using a given search criteria. Now, the single table database, if we are to define it, this is a database that is storing all the data within a single table. So it's made up of fields and records only. And a field is a column where we are storing our data, and a record is a set of characteristics that define an entity within the database itself. So it is suitable when data is simple and no complex relationships required. That's where we might need a single table database. Now, let's get into data types that we find. Normally, for textual data, we might store it as a string, things like name, address. Sometimes we might need gender itself, though it's a single character, but as long as it's in alphabet form, we can store it as a string or text. Then we also have a whole number data, like quantifying units of items, how many apples have been sold. That will be in integer form. We want to look at a minimum value of a certain quantity, like starting from 20 going upwards. So that data type is going to be integer. Then we also have data that flows about a point. In other words, they involve decimal points. So that data, we call it decimal or real. Then we also have data that takes only two possible states, yes or no, true or false, one or zero. That is called a Boolean. Then we also have date itself as a data type that is used to store date when an event occurs or happens. Let's have a look at the primary key. We said primary key, it uniquely identifies a row within a table, and normally that row, we call it a record. This key must not be empty because it's very, very important to uniquely identify given set of data or information within our table. And this unique key, it must not also be duplicated because we don't want a conflict to say when we pick that key, which record exactly is it pointing to. Now, examples of primary keys can be book number, student number, employee code. All those, they are examples of unique identifiers of data within a database. Then next, we want to look at how we define queries. We want query to, question or to ask our database to provide us with responses or information. I'm interested in all the female students within a school environment. So we are prompting to say, can the database give us a list of all the students who are female by gender? So that's an example of a query. Students write a test, you're interested in all those who score below 40. So you can prompt to say, can I have a name where, that's a condition, marks are less than 40. Or sometimes you might be interested in all students taking a particular course or subject. For instance, subject equal to English. So because English is a text, you surround it by course. But if the data that you're querying is in integer form, there's no need for you to surround that particular data by quotes. Right, still proceeding, we now have 10 worked examples that we are going to walk through together. Our interest is to say from our discussion, are we able to draw or come up with answers to such? So the first problem, we are trying to identify if a single database would suffice for a school that wants to store student ID, name, age, and class. I think for this scenario, uh, single table database would work for this given scenario. Then the next step, we are interested in designing the table. This table, we're going to name it student, but what information do we need? And normally it's important to start by identifying the primary key itself. So each student should have maybe a unique identifier. We might call it a student ID. So let's talk of student ID, and this is going to be our primary key. Yeah, but because these keys, when they come, sometimes they are a concatenation of special keys and numbers. But if we assume that it's only made up of numbers, because in the school environment, sometimes we don't have very large numbers, so we can categorize it as an integer in terms of the data type. But each student also needs to have a name. So when we have a name of the student, the data type obviously is going to be text. What other information do we think we might be interested in? Each student has got age. So age there can also be an integer because age is a number. And we assume our age is going to be in whole number form. Then a student might belong to a class. So the class that a student belongs, sometimes we call it Form 1 group. So this data is going to be text in type. So we have managed to do a definition of the design of our table student to say within our table we expect to have these fields student ID, name, age, and class, which we are going to populate or fill with information. Now the next aspect that we want to look at is choosing a primary key. Why is it important to choose a primary key? Something that is unique to identify a record within a table. So primary key should not be easily repeated or duplicated. Why are we saying so? Because we want to uniquely identify a record within our table. So if there is duplication, then it means we're going to have conflict when we are querying or asking our database to provide us with results or information. A good example of a poor primary key choice can be name, for instance. Why do we say it's a poor choice? Because more than a single student might have the same name, they might share the common name. Then the next problem we have here is choice of data types. For instance, the field here is date of birth. So what is the data type? The data type is actually date because that's the type of data that we want to store. Next, we are interested in looking into the library database. Now, this library database has got the following fields. We have got book ID, title, author, and price. Now, one important thing is to quickly come up with our primary key. So this is going to be the unique identifier of all records that we have within the database. So for this case, our primary key obviously is going to be book ID because we expect it to be unique. Then on the next problem, we are interested in querying our databases. And here we are interested in marks that are bigger than 50 or equal to 50. So the query is going to be written like this, thus asking the database for all the marks that are bigger than or equal to 50. Then next, we want a text-based query. But now, if this query involves text, then it means we're going to surround the word of interest itself around course. So we want to find all students in Form 4. So we could say class year, class has to be equal to inside the post we have the form that we want to use to select or query the data. So that's the basic examples of queries that we would find if we want to retrieve data from our table or our database. Now, next, we are interested in multiple criteria. In other words, you are putting one or more than a single condition for you to draw or to pick data from the database. So the first one, if I want all females, it means I'm interested in observing the gender to be, we want the gender to be female, and it's a character there, so we will surround it by cos. Then age, want age equal to 15, so we'll prefix it to 15, and we don't surround in integer by cos. Then the last problem we want to look at is example 10, understanding a query result. A query returns 8 records. So what does it mean to us? It means 8 records met the specified search criteria. I think that's it for the introduction to databases and focusing on a single table database. Let's meet again as we discuss about what's to come in the next series, which is similar problems as we have had on the first 10. Bye for now.